Hello everyone, this is Will Ramey, Product Manager for GPU Computing Technologies here at NVIDIA. I'm here today with Stephen Jones, our Product Line Manager for Developer Tools.
Hi everyone.
And we'd like to share with you some of the exciting new features that we're announcing this week in the CUDAToolkit 3.2 release candidate and also in ParallelNsight version 1.5 for Visual Studio. So the new features in the CUDAToolkit version 3.2 are building on top of over 3 years of functionality that we've been putting into the CUDAToolkit. And in this release, we are adding 2 new libraries. One is a sparse matrix multiplication library called cuSparse. This adds support for sparse and dense sparse matrix operations in addition to the dense matrix operations that have been supported in our CUDA-BLAS library for a number of years. We're also adding a new random number generation library that has support for both the Sobel and XOR WOW random number generation algorithms. So you'll have support for both pseudo-random numbers and quasi-random numbers in your device code. We've added support for the new 6 GB Tesla and Quadro products that have been announced. And we've also added support for multi-GPU debugging. And this means you can set a breakpoint on one GPU and then seamlessly step across and inspect the state on the other GPUs in the system when the breakpoint gets hit. We've invested some significant effort in performance improvements in our libraries for this release. And so you will see up to 30% performance improvement in the FFT library and somewhere between 50% and 300% in the BLAS library routines. Really impressive effort from our library team on this. We're really excited to be sharing this with you. We've also added some new cluster management features. As more and more GPUs get deployed in cluster and grid computing environments, the ability for the system administrators to get access to information about how the GPUs are being used in the system by various jobs and understand and keep track of that for monitoring management purposes as well as for billing purposes in some cases has become increasingly important, so we're continuing to provide features in that area. And we've also, in this release, integrated support for the Tesla compute cluster mode into the basic driver package. Now, if you're not familiar with what the TCC or the Tesla compute cluster support is, this is a special set of functionality in our drivers that we introduced last year for Windows clusters. And it's basically a re-implementation of our CUDA driver API on top of a lower level device driver interface provided by the Windows operating system. And by targeting this lower level driver model in Windows, it gives our customers the ability to use remote desktop connections, the Windows cluster management services, and also to run GPU accelerated applications as services without having an interactive user logon session on each node in the cluster. It also delivers some significantly increased performance in the form of much lower overhead for kernel launches. And so that's a key benefit for a number of our customers as well. And all of that functionality has been available for about a year now. And what's new in this release is we've taken all of that functionality that used to be available in only a separate standalone driver package that had to be installed exclusive of the normal driver package, and integrated that functionality as a mode into the normal driver package. So now you can have, for example, some GPUs in your system using the normal full functionality of the driver package with graphics interoperability and say use a Quadro GPU for accelerated visualization, and then have one or more Tesla GPUs in the system configured to run in TCC mode to take advantage of the additional flexibility and performance that's available in TCC mode for GPUs that are performing compute-only operations. So that's the summary of the feature highlights in the new CUDAToolkit 3.2 release candidate. Let me turn it over at this point to Stevens Jones, who can tell us about the new features in ParallelNsight 1.5.
Thanks, Will. So for those of you not familiar with ParallelNsight, let me give just a quick overview. So ParallelNsight is the first development environment that's integrated into Visual Studio that supports GPU computing technologies. Within Visual Studio, it makes it as easy to develop applications for the GPU as it is to develop applications for the CPU. It also provides the developer the ability to tap in to the speed and the power of the GPU while leveraging the flexible workflows and comfortable environment that the developers are used to working on every day. So within Visual Studio, developers can now build their GPU applications, they can debug them, and they can profile them. So let's talk about some of the specific feature highlights of ParallelNsight 1.5. ParallelNsight 1.0 was supported in Visual Studio 2008. We've now introduced support for Visual Studio 2010. So for 2010, Microsoft really made a major commitment to bring parallel multi-core development for the CPU to a wide variety of developers. So at NVIDIA, we've brought ParallelNsight into Visual Studio 2010, providing parallel development support for many core GPUs. So this really makes Visual Studio 2010 the premier development environment for parallel applications. So we're really excited to have ParallelNsight available within Visual Studio 2010. In addition, we've added single system debugging, which is a feature I'll dive into a little bit a little bit deeper in just a minute. We've added support for the Tesla Compute Cluster debugging. This is the driver mode that Will mentioned just a moment ago. We've also added support for the 3.2 version of the CUDAToolkit, and we've added new hardware that has been made available since the original ParallelNsight 1.0 release. So, I mentioned this new development configuration that we've introduced for ParallelNsight 1.5. Let's talk about the flexible configurations in general. So, the first configuration is a single machine with a single NVIDIA GPU. And this enables the system analysis and the graphics inspector functionality. Our new single machine dual GPU mode that we've added adds compute debugging to these other two functions. So you can imagine that when we're debugging on the GPU, when you set a breakpoint on the hardware, it's actually going to stop the GPU at that breakpoint. So if you're updating, if you need to update your desktop, that's not going to function correctly. So in this single machine dual GPU configuration, you set a second GPU as a headless GPU, meaning it's not connected to a monitor. Your primary GPU is going to update your desktop, and your secondary GPU is going to be where you execute your GPU compute code. This is a great configuration for development houses that might not necessarily have multiple machines available, but can place multiple GPUs within a single machine. Another configuration is two machines connected over a network. When you have this configuration, it adds the graphics debugger functionality. The development machine or the development host, this can really be any system from a laptop to a desktop machine. Doesn't even necessarily have to have an NVIDIA GPU, because all the work is going to be occurring on the debug target. Now this debug target could be another desktop machine on your desk, or it could be a back-end development pool that's utilized by a host of developers within an organization. Very flexible configuration, supports all of the ParallelNsight functionality. And finally, there's the workstation SLI configuration. This is very similar to the network configuration, but it's all packaged in one box, leveraging our SLI multi-OS technology in conjunction with Parallel workstation that enables you to run a virtual machine on the box and dedicate a hardware GPU to that machine. So finally, I want to talk just specifically about the ParallelNsight 1.5 features. So there are two editions of ParallelNsight. One is the standard edition that's available at no cost, and it supports CUDA C and C++ debugging, direct compute debugging. It supports our graphics debugging and graphics inspector functionality. The next edition is the Professional Edition. It's available at $349, and the Professional Edition adds CUDA C++ analysis, OpenGL and an OpenCL analysis, as well as the graphics analysis. It also includes the new Tesla Compute Cluster debugging that we mentioned previously. The Standard Edition is available today. The Professional Edition is currently in release candidate. We encourage everyone to jump aboard and help us evaluate that package.
Thanks, Stephen. So as you can tell, we're really excited to share all of these great new features with you. You can get the latest version of the CUDA toolkit at nvidia.com/getcuda, and you can download both the standard version and the professional version of ParallelNsight at nvidia.com/getParallelNsight. There's one last thing I wanted to make sure and share with you before we end today. The GPU Technology Conference is happening here in San Jose next week, and we hope that you all are planning to join us or will be able to join us. For those of you who have not registered yet, there's a 10% discount code up there on your screen, and you can use that just by going to nvidia.com/GTC and following the registration instructions. Thanks again for joining us today, and we'll be talking with you soon.